This is Unit 2, Exponential Functions, and we're actually starting today with Day 1, Function Operations. We'll be getting to the exponentials in a couple days on this unit. Starting though with the operations of functions, we're going to see where we can do function addition, subtraction, multiplication, and division for these first couple problems. Now this is a pretty straightforward process. They'll use different letters to denote different functions, and they'll show you what operation is expected of you to simplify. Here we're doing f plus g of x. To do that, what you'll do is you'll take the f of x function, which is the 3x squared plus 7x, and you will add that to the g of x function, plus 2x squared minus x minus 1. You can see that I actually placed those functions in parentheses. Really not going to make much of a difference here since there's nothing to distribute to the g of x function or the f of x function, but it's a good practice to get into because when there is something to distribute or when there's an operation to complete there. So I'm going to go ahead and get into this. This will go into combining like terms. 3x squared plus 2x squared makes for 5x squared. 7x plus negative x will make positive 6x, and then there's nothing combined with the minus 1 at the end. This would be my simplified answer for f plus g of x. For this one, it'll be f minus g of x, and it is very important which function you are putting first. So the f of x function, the 3x squared plus 7x, as it was before, will now be subtracting away the g of x function, which is 2x squared minus x minus 1. So in this problem, it's an example of what I was saying, where there will be something to actually distribute to the g of x function. So I'm going to have the f of x function, 3x squared plus 7x, nothing to distribute there. But over here, I need to distribute the negative sign to each of these terms to make it minus 2x squared plus x plus 1. And now I can combine my like terms to wrap up for my final answer, which will be 3x squared minus 2x squared is 1x squared. 7x plus x is 8x, and then I have a plus 1 at the end. I am done. Function addition and function subtraction, very straightforward. Now we'll move into function multiplication. These are different functions. Be warned, for example, too, I changed what f of x and g of x are. Alright. Moving right into it, for f times g of x, I will take the f of x function, which is 2x squared plus 3x minus 1, and I will multiply it by the g of x function, which is x plus 2. In order to do that, I will distribute appropriately, and what that will look like is x is going to multiply all these terms, and then positive 2 is going to multiply all these terms. So if you want to write it first of all like this, where x multiplies the x squared plus 2x squared plus 3x minus 1, and then I'll distribute the 2 to all of these. You could have obviously done 2x squared multiplying x plus 2, 3x multiplying x plus 2, negative 1 multiplying x plus 2. I went the other way around. Now I'll distribute this x to each term and distribute this 2 to each term. A lot of times people don't write this second step that I just included, but I was showing it for an example. So now I'll have 2x to the third plus 3x squared minus 1x on that first one. And for the second group, I'll have plus 4x squared plus 6x minus 2. And now I combine my like terms. So f times g of x is equal to 2x cubed, has no like terms to combine with. It will have a plus 7x squared, a plus 5x, and then minus 2 has nothing to combine with. All I was doing there was combining my like terms in the middle. And that's it, final answer. Now for division, we're going to touch on it right now since we're talking about function operations. We're not really going to do too much with function division in this unit. That's going to come more later when we start dealing with rational functions, and when we start dealing with polynomials, we'll see a lot of division and you'll see what to do then. But simply put, what this would equal right now is 2x squared plus 3x minus 1, the f of x function, divided by the g of x function, x plus 2. Now, that's as far as I'm really wanting you to go right now for this kind of problem. What I'm going to show you later in this course is how to simplify things like that. Also telling you what values it would be undefined for. For instance, x could not equal -2 right here because you'd be dividing by 0. Just something I'm pointing out right now. We're in the middle of function operations, might as well show it, but there it is. Now for function composition, by far the toughest thing for today. Function composition is when you take one function and insert it into the independent values for another function. So I have f circle g of x. This is not multiplication. It is an open circle. That is when you have f of g of x. Sometimes you'll have f of g of x, sometimes g of f of x. I'm going to treat that as two separate examples, and here we go. Starting with the f circle g of x. Alright, what I'm going to do is I'm going to have f of g of x. What that means, when I'm evaluating this down, it's going to be f of the g of x function, which I could replace with 2x minus 1. I'm using simple substitution right here. Now, I'm going to figure out what f of 2x minus 1 is. I know what f of x is. It's 3x squared minus x plus 4. Let me write that down really quick. 3x squared. Now you might be like, why did he leave that blank? He knows it's x. No, I do not. It's actually 2x minus 1. So 3x squared minus x plus 4. But where there were x's, I'm now inserting 2x minus 1. And I will simplify all of that down. Now this takes a little bit of work. You got to be really careful as to multiplying it out correctly. For instance, 2x minus 1 squared is 4x squared minus 4x plus 1. That's a perfect square trinomial. It's 2x minus 1 times 2x minus 1. Over here I'll distribute the negative sign to the 2x minus 1, so it'll become minus 2x plus 1. Plus 4 at the end there. Here I'll distribute the 3 out, so 12x squared minus 12x plus 3 minus 2x. I'm going to go ahead and combine 1 and 4 to make it 5. And combining my like terms now, I get a final answer for f circle g of x of 12x squared minus 12x minus 2x makes minus 14x plus 8, 3 plus 5. That is my answer for the composition of f and g of x. Inconveniently enough, I will get a different answer for this problem. The problem I just answered was this part. This would actually be a different answer. I'll show that now. Okay, moving on to g of f of x. So this time it's going to be the reverse, where I'm actually taking the f of x function, plugging it into the g of x function. Fortunately, this will actually be a lot less work. Alright, this will be g of, let me go ahead and write in what f of x is. It's 3x squared minus x plus 4. And now I'm going to take that stuff and I'm going to insert it into the x value for the g function. So it'll be 2x minus 1, 2x minus 1, but instead of x, I now have 3x squared minus x plus 4. Now I'll simplify that down and have my answer. Fortunately on this one, all you got to do is distribute the 2 to the 3 terms there and then combine like terms. So my final answer will be 6x squared minus 2x plus 7 is what g of f of x is. And I'm done. Now, if you're in my class, in the room, I'm going to show you how to actually evaluate for values on the calculator. It's a little tricky though, and I want you to be in person whenever I go over that. So please ask me if you're absent for this. Let me know what I can do when I can show you how that works. And there's your assignment. Please let me know what I can do to help. Thank you.